get started? We're finishing chapter 9 today. We'll start chapter 11 on Tuesday. Next week, chapter 11 Thursday. And notice chapter 11 goes into a third lecture. We'll play it by ear. Maybe we won't need the third lecture, but we'll see. Whatever the case may be, right now the quiz is scheduled for the 29th. I can't imagine moving it up to the 27th, but there's a small possibility, but so most likely it's the 29th. Just 2 chapters. By the way, this chapter, the big picture, you may have noticed from Tuesday's lecture that it's really kind of one of the easier chapters. I hope you're seeing it that way. I mean, right now, do you feel confident you can do a forward pass and a backward pass with known activity times? I only see about 5 heads shaking. Yes, that's it. Man. All right. Well, let's see where we end up here. You have an in-class assignment today. Homework going to be posted in a few hours. That'll be due on Tuesday. Here's what we left off. This was the formula. We talked about activity time being known, and I told you the example I gave you is like construction projects. It's pretty easy to get pinned down the activity time for doing drywall or whatever the case may be. But in the real world, most of the projects I've ever been involved in, activity times can't be pinpointed, and so they're more like estimated. And the usual rule of thumb is you want to estimate a range and a most likely somewhere in between that range. And it looks like this. You get 3, you break it down to 3 possible times for every activity like this. And then here's the formula with what you do when you get done with those meeting after meeting after meeting, trying to figure out how much time each activity would take. And you take each of the times, and you use this calculation, and you use that as what's called the expected time. Once you convert this to expected time, you do everything the same that you did when you had known activity times. This is the difference. 4 times the most likely time, which is the time in the middle. Then you take the shortest amount of time and the longest amount of time added to it, so that's 6 numbers there. 4, 5, 6. Then divide by 6. That's how you then take that time and make it most likely. Now don't make the assumption that the most likely time is going to be right in the middle between the longest time it could take and the shortest time it could take. That's not always the case, as you can see in activity B. So what's nice about this is that, well, kind of nice, is that we can utilize these longest amount of time and shortest amount of time to see how much activities vary. There's variance there because of this estimation being done. And by using this variance of these activities, we can convert it to a project variance. You'll see how easy it is. Really easy. Once you have that project variance, you square root it to get the standard deviation, which will allow you then to calculate any probability. There's that word, probability. So here is your moment of review. That look familiar? Make anybody sweat? Because they had trouble, hated stats a little maybe? I don't know. What's in the middle here always is the mean, right? The average, the mean, the expected. Well, that's the same with this project management. This is the expected time. Even with uncertain activity times, this is going to be the expected time right here. Once you do all the math out and say, okay, this project's going to should take this long, based on all the math, there it is. Now the empirical rule says if you go out, let's see, I want to do this right, and I forget, about this far on the curve, I'm just looking at the curve, I'm trying to hit the points on the curve. That's usually 1 standard deviation above and below the expected time, or whatever the number is in steps. Then you go about this far, and that's usually about 2 standard deviations. Then you go all the way out here, and that's about 3, and usually 99% of your results or your expectation will be within 3 standard deviations above or below the expected whatever. In stats, if it's outside 3 standard deviations, it's usually called an outlier. And there's usually only 1 or 2 pieces of data that might be out there, and you just kind of say, oh, that's an outlier. Something happens, something's weird about it, you take it out of the picture and you use the data except for that one. Now, let's get this back to project management. You ready? I want to make sure you understand, this is nothing but a number line. It's just a number line, and you decide what numbers to put on it based on what's the expected time or what's the mean. And then, once you calculate standard deviation, you'll add one standard deviation and you'll know what this number is on the number line. You add a second standard deviation, you'll know what this number is. Subtract, and you'll know what those numbers are. Hypothetically, let's pretend the project time is 28 days. With a standard deviation, let's make it 1.2 days. And now I can fill in this number line with that information. Right here's our expected time. One standard deviation above is going to be 1.2 days above it, so that's 29.2. Two standard deviations, I'm going to add another 1.2, so now I'm at 30.4, and so on. Let me subtract, go the other direction. So this is 26.8. Someone help me if my math's off. 25.6, 25.6, that sound right? And so on. So, in the front, or in the back of your book, let me get a page number for you here. We're getting to those blue pages, right where the answers are to even problems, wherever that is. No, I guess they're not blue. Yeah, they're blue. So it's page 815, it looks like. It's not numbered. 815 and 816. 816 is numbered. This is your, this probably will look familiar a little bit. You know. There's your little bell curve. And basically it's saying, okay, if what it is you're supposed to measure the probability of is below the mean, you're going to end up getting a negative z, and you can measure then what that probability is from any point here on this number line to the left. But if the question's, for example, if I said the question is, what's the probability that this project will get done in 26.8 days or less? Well, that lands right at one standard deviation out. So it's always whatever you're being asked about minus whatever the expected result is, mean, divided by the standard deviation. Well, you do the math on this, it's going to be -1, because I picked a number that happens to be exactly one standard deviation below. And so, I look up now the -1 on my chart, 1.0, because it's 1 on the nose. The probability of the time being 26.8 days or less when the expected time's 28 days with 1.2 days standard deviation is about 15.87% chance. So if I said to you then, what's the probability it's going to be 26.8 days or more? Should be very simple for you to quickly say the opposite, exactly. And what he just said was, he just went and said 100% minus 15.87. What'd you say, 83?
I thought it was 7.
Oh, okay. Which would be 100% minus that is about 84.13, I guess. Is that right? So there's about an 84.13 chance that it's more than 26.8 days. Now let's try this again. The story says, hey, I've got this all lined up for our cash flow as long as we get this project done in 29.2 days. So I need to see what the probability is that, you know, it's not going to get done in 29.2 days. That it's going to maybe take longer than 29.2 days. Whatever you're being asked about, minus the expected number or mean, if you want to talk about any data, divided by the standard deviation. This time our answer is +1, because I picked the number purposely as exactly one standard deviation above the mean. And so we could look up +1 on the next page, right here. And this right here, 1.0, because there's no other digits to the right, and the probability is 84.13%. Well, what a coincidence. And that's, though, if of the project getting done in 29.2 days or less. Remember, these tables are always giving you the probability of any amount of any number or less to the left. But the question is, hey, what's the probability this is going to take longer than 29.2 days? Because if it's going to take, on the 29th day, I start paying both interest and principal on this bridge loan. And my cash is going to get sucked away fast if we don't have that revenue coming in. And that's what this project's going to do, generate the revenue to pay that loan. That's the whole point. And so you look this up and you go, well, if it's 84% that it's going to take less than 29.2 days, I can't help but laughing using his phone as a mirror. Can't help it. Caught me off guard. 84% chance. So what's the probability it will take longer than 29.2 days? The opposite is 15, a little over 15% chance. So you're a manager. You are in charge of cash control. If you run out of cash, it's coming down on you. You got a 15.7% chance, 15.67% chance that you're going to run out of cash. Do you feel comfortable with that? And I don't know if I do. Matter of fact, I would rather have a 10% chance or less. I want the odds to be hugely my favorite. I would love it like to be a 1% chance. So it's at that point that I got to start talking to the bank or whoever it is. Maybe we did a bond issue to get the money, whatever it may be. Most likely a banker or commercial lending bank. And I need to start negotiating to try to move the time in which this schedule is set up to pay this back up to increase my odds. I have that meeting, Comerica. I used to go to Comerica down in Detroit's Renaissance Center all the time to negotiate things. I'm down there, had this meeting, and they said, okay, we can do this. We can take you to 30 days. On day 30, though, boom, it starts. What's one day? Pretend this is weeks, whatever, because probably it'd be more significant. So now, what's my probability? 30 minus 28 is 2. 2 divided by 1.2, help me out, calculators. 2 divided by 1.2 is 1.67? Thank you. 1.67. Positive because it's above. It's about right there. To the left would give me the probability that this will get done in 30 units of time or less. We look up positive 1.6. We go to the next digit, which is a 7. Help me out, am I there? No? Right here. There's a 95.25% chance it will take less than 30 days. I've now set myself up for disaster at only about a 4.75% chance of a disaster, meaning it's going to take longer than 30 days. And I like that much better, feel much more comfortable. I'm so glad we negotiated this far enough in advance that everything could be worked out. This could be weeks or whatever, where that is significant, or months even. That's very significant. And that's where this really helps you, in the planning stages. Because if you waited until the last minute, you're only a month away from this project finishing, and you finally come to the realization, oh my God, this is not getting done in time. There's no way we're going to have some revenue coming in on day 30, or day 31, or 32. And then you go to negotiate with the bank, they got you. They realize it. They have the leverage, is what I used to call it. They have the arm. And they're going to win. And they realize that. There's nothing, hey, you're so close. You should have talked about this before you got started. By planning ahead and negotiating this in advance, if they don't work with you, you're still in the opportunity of switching to another bank, and all that interest could go to them. They realize that. That's why they went ahead and worked with you and renegotiated at the very beginning, because you aren't at the point where you even got the first third of the loan yet. Don't forget, bridge loans in business, 1/3, 1/3, 1/3, boom, then you start paying it all back. Meanwhile, you're only paying the interest along the way, which is a very small amount, because you only borrowed 1/3 to start with, and then you got 2/3, and you're just making the interest payments. Way less than the whole big picture. Everybody see this, right? Everybody, this kind of refreshes your memory how to do it. Okay, let's get started. Here we go. All right, by the way, you want to get variances for different activities. And I gave you a hint on Tuesday to save you a ton of time. I said you don't necessarily have to calculate the variance of every activity. I said you only need to calculate the variances of what?
Critical.
That's right. That's right. Critical path. Critical path. Because it's the critical path that's going to tell you the variance of the project. And it's the variance of the project that will allow you to calculate the probabilities you need. And here is how to get the variance of of each activity. The longest amount of time minus the shortest amount of time that activity could take, divided by 6, then take that and square it. Here's our example. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 activities. You can see what precedes each activity. Multiple activities precede other activities. Shortest amount of time called the optimistic, longest amount of time called pessimistic, most likely time, right? We do a forward, we set this all up, we chart it. Again, I'm not going to make you draw that. If this is involved, I'm handing this to you, but it is going to be blank like that. And you decide, okay, I'm going to do my forward pass, little refresher, we might have time for this. What number would be the earliest start time for activity A, just to make sure remember how to do this? And what would be the earliest finish for A? Very good. What would be the earliest start for E? 6, right? And what would be the earliest finish? What would be the earliest start for D? 6, that's right. And earliest finish? 11, okay. Making sure we're there. Earliest start for B? 0. That's right. Earliest finish? That's right. You're on the track. Let me just test you here, see how good your memory is. That's better than mine. Earliest start for F. Let me think this through before you answer. I got to think a minute. I forgot already. Okay, got it. No.
9.
Yes. Who said that? Thank you. Eric, thank you. Eric? Okay, thanks. 9. Because it's preceded by 2 different activities. C's earliest finish is a 9. B's earliest finish is a 4. Both have to be done before F starts, so it can't, even if this finishes a 4, it's got to wait for this one to finish, which is 9. 9's the earliest start. Add 4, we're at 13, right? Boom, 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 we go back. What's the rule going backwards when you have more than one activity after it? To use the least amount or the most amount of the latest start time of the activities? The smallest amount, the least, that's right. The lower a number compared to the larger. So it's the bigger number going forward, the bigger number going forward, the smaller number coming back. That's kind of the rule I try to remember. So like remember, when you have that decision of more than one activity, one direction or the other, it makes it a lot easier than just to figure out which number to use. Okay, you do your forward path. You calculate. See, this is what I don't want you to do. Don't spend all this time calculating all these variances, because you're not going to use them all. You're not even going to use half of them. And if this is on a quiz, look at all this time that you've taken. And these could be in decimals instead of fractions. But you may need the expected times, because you can't do your forward and backwards path without getting calculated the expected times. Once you have those expected times, you treat it just like the previous one with known activity times. And it looks like, where is mine? Here's your forward pass, here's your backwards pass. If you had a picture of this and I said, calculate the slack for activity H, you give me what number? The slack for activity H?
1.
Thank you. And for those who weren't here on Tuesday, all they did was look at either the latest start and the earliest start and find the difference, or the latest finish or earliest finish, find the difference. And when you find an activity that has no slack, you found what? Critical activity. Very good. See the critical activities highlighted? When you look at the critical activities, you are now all together as one. You found the what?
Critical path.
There you go, critical path. That critical path is what it's all about. The critical path is what's going to tell you your variance of the project. So now we pick out A, C, F, I, and K's. By the way, what's the expected completion time of this project? 23 units of time, whatever it may be, right? 23, because we look at whatever goes directly to the finish, and whichever one has the latest, earliest finish is the project time. We've got a 22 here and a 23. So that's our project time, 23 units of time. We pick out, the critical path, and we're now going to calculate the variances for A, C, F, I, and K. We're just picking those out. I already forgot. A, C, F, I, and K. Does that sound right? And we're picking those out. We just calculated those, saved a ton of time, because we only did like 5 out of however many. And then we take those variances and add them. Just like that. 4/9 turn into a decimal, whatever. C has no variance. Well, how could that happen? How could an activity have no variance? Huh? I heard something.
Optimistic time, pessimistic time, and most likely time.
They're all the same. It's one activity that we were all able to agree exactly how much time that activity would take. There was no, we know that one for sure. So the optimistic, the pessimistic, will all be the same number because this is one activity that everybody can agree on, which means it has no variance. 1/9, 1, 4/9, add them together. There's your project variance right there. Adding the variances of your critical path is what gets you to this. Now square root it. Square root it, you just found your standard deviation of the project. What was the expected completion time? I forgot. 23 units of time, whatever it may be. Days, weeks, hours, I can't remember. Probably hours, but we'll just call it units of time because it could be anything. So now you can answer any question. Once you have that standard deviation and the expected time, you can answer any of those probability questions that I may throw at you. It could be, what's the probability of this getting done in 24 units of time or less? What's the probability of this getting done in 24 units of time or more? What's the probability it's going to take 25 units of time or more? Because, when we put this all together, I saw it was going to take 23 units of time, so I've negotiated 25 units of time on the paying the principal. So I want to see what the odds are of me starting to run out of cash. Always, whatever the question's asking about, 25 units of time or more. I'm straying from the PowerPoint here, you guys, because that one's 24. And I'm saying or more, minus whatever the expected time is, divided by the standard deviation of the project. So we got 2 divided by 1.414. Calculator. Where's John? What's he doing? Come on, help me out. Help me. 25 minus 23, 2. Divided by 1.414. 1 point. Come on, calculator. You have your calculator. I didn't realize you're on the internet. I thought you were playing with the calculator. Anybody else? Anybody? Have a calculator? Do I need to bring Alexa to every class?
1.414.
She's my new best friend. Outside. What'd you say? Seriously? Oh, because the square root of 2 is 1.414. All right. We go to our chart. And we go to our chart. It's a positive 1.414 because what we're asking about is above the expected time. 1.414 should work. Gosh, I would accept either answer, 1.41 or 1.42's probability, but show off and give me a probability that's between them. Because really, this is kind of almost right between them. You can make one up, and if it's right between them, I'm going to take it. I'll take any of those numbers between them. So, tell me the probability of this being done in 25 units of time or more. I got to look. I hear someone.
7.93%.
Boy, hang on. I heard it. Say that again. Who said it?
7.9.
No, that's or less. That's or less. Or more is the opposite, though. All I got to do is subtract from 100%, and you got
7.93.
7.93%, she says. Let's check it out. And did you show off and pick something in the middle? Darn. Anybody? Marco, give it to me. Oh, man. Jeez. All right, here we go. 7.93. 1.41's there. 1.42's there. 100% minus this is going to be 7 point. This is the one you use. 7.03 or 7 point. I'm lost. 7.93. 7.93. This one would have been 7.7. 7.8. So what would be between that? 7.78, 7.98. About. Let's just call it 7.8. How's that? Now I'll take 7.93. I'll take the other one we just said. 7 point whatever, or anything between them I'll take. Because as you can tell, we went out enough digits to where it would be kind of between them. I'll take any of that. But you got to watch the words. When I say more than, this always, don't forget, anytime you use either page of this chart, it's always giving the probability for less than. Always. For less than. And if the question's asking for more than, you look it up and find the opposite. Go ahead, Jeremy. Both pages. See how the shading's always to the left on this page too? This is giving you the probability of any number to the left of the middle to the left. And then the other one's giving you the probability of any number to the right of the middle, but to the left. And so if it's asking more than, whichever, as long as you set this up correctly, whatever you're being asked about, minus what's expected. Oh yeah, this problem is 23, that's why. Then, as long as you set up this way, this will always be giving you the probability for less than. 25 days or less, yeah, 25 units of time or less. So you gotta use the opposite.
So if the number is larger on the left side?
No, smaller on the left side. Because right here, this one, our expected time is 23.
No, if you set up the problem, I got it.
So if I said, what's the probability will take 21 units of time or less? Now that's on the left side. So you do this, you go, oh, that's 2, divided by that's this, but negative. And then you look up the negative one, you're finding the probability of 21 units of time or less. Which is the answers we were talking about for the other one because we were doing no more. And we happen to have the exact same, but a negative. About 7 point, in fact, I used to always look up the opposite just so I wouldn't have to subtract it from 100%, which did save me time. What is this, 1.41? I don't want to lose anybody with this confusion right now. But 7.93% or 7.78% or anything between there, like 7.8%. If I was asking for 21 days or less. So if I said, what's the probability it would take 21 days or more, it will be the opposite of that, 90 some, or 80 something percent, 87%, 82.2%. Does that sound right? Now, in this example, this was, yes, this project will take 23 units of time. The question was, what's the probability it would take 24 units of time or less? Not more, less. Whatever you're being asked about, minus the expected time, divided by standard deviation, gives you a positive 0.71. You look up 0.71, and it's 76%. You don't have to subtract it from 100%, because this question was, what's the probability it would take 24 or less? It didn't say more. Everybody see it? I hope I made statistics seem a little easier. All right. Yes.
Okay, I understand it, but how can I know about within 24 hours?
How do we know if what?
24,
24. Oh, how in this question it will say, you'll do all the whatever, and you just go, oh, it's going to take 23 units of time, and then there'll be a written question. It will say the critical path is A, C, F, I, K, and the expected time is 23 units of time. What's the probability it will take? And then you'll be given this number, or less, or that number, or more. We've got to look at the words with the number, or less or more. Everybody okay? Okay. Now this is where I start to lose you a little, but I'm going to break it down to make it as easy as I can. All right? I'm going to get you to this part here, and then go back to the story. Okay. All right. Don't let this scare you. I'm going to break this down, but what I want you to notice, here's what I want you to notice. There's an X variable and a Y variable for every activity. Start right there. This is called crashing a project. I'm going to introduce you to in a minute, but I want to get you little rules down on crashing. There's 2 variables for every activity. So if there's 6 activities, how many variables? 12, exactly. There's 10 activities, how many variables? 20. 2 variables for every activity, an X variable, a Y variable. The Y variables always represent, the Y constraints are always representing a less than equal to however many units of time that activity can be reduced in time. That's what crashing is all about, which I'm about to tell you. So the Y constraints are always less than equal to however many units of time that activity could be reduced, called crashed. The y variables are always the ones you put in the objective function in a crashing project, when you're crashing a project. Let me say that again. The y variables for the activities are the ones you use in the objective function. The numbers in the objective function are always the cost per 1 unit of crashing that activity. Say that one again. The numbers in the objective function are always the cost of crashing 1 unit of time for that activity. Crashing 1 unit of time for that activity, there's the cost. So if I said to you, hey, we're thinking about crashing activity H, 2 units of time, what would be the cost?
700.
I heard it over here.
700.
700. Because you could just look at this and go, oh, this is the cost for 1 unit of crashing time for activity H. And I said, what's the cost for crashing 2 if we decide to crash this one? 700. The only catch is that I don't want you to get confused is, in order to save space, the objective function is in thousands. So that's really 20,000. So that's 350,000. So that'd be 700,000. But this whole thing's in thousands just here. This is the only part that's in thousands. So just left the zeros off just to make it easier for the PowerPoint. All right, we ready now? Oh, and these are all the activities. When we look at the activities, and this I was going to show you how this is done. If you take good notes, you can write any of these like that. It's all about the process of how these are designed. But what I want to add to you, how important these two are. These represent any activities that are going directly to the end if you drew the picture, which mean that H and I do not precede any other activity. Remember that when we draw these out, the arrows go to the finish for any activities that do not precede another activity? Well, these are the 2 that do not precede any other activity. And you will always put these activities that do not precede any other less than equal to whatever amount of time you're trying to crash this down to. Let me say that again. The activities that do not precede any other activities are always set up to be less than equal to, their x variables are set up to be less than equal to whatever number of units of time you're trying to crash this project to. So I can see this is being crashed at 26. So when we get to the story, I know that this activity was calculated to take longer than 26 units of time. And we decided that we need to get it done in a shorter period of time. 26. I don't know what the expected time is, but we need to get it done in 26. You have to come up with how to get it done in 26 before we even start the project. And that's the real world right there. And you have to figure out a way to get it crashed to 26 units of time at the least amount of cost possible. That's what this does. It just steers you right to the quick solution, the best solution of here's the activities that should be reduced in time, here's how much it costs to get these activities reduced in time, which then allows our project to be done in less amount of time. All right, you ready for the story and the description here? You're working for this earth moving company. You've been handed this project. It's a new loader, right? Manufacturing road construction equipment, pavers, rollers, graders. The company's faced with this new project, a new line of loaders. Hey, you've been here for a while. You're a shining star. We're handing you a project. We want to do a new line of loaders. Take the lead on this. Start with your meetings. Start coming up with each activity that will get you to the point of these new loaders. Figure out the times. Get this all planned in advance as fast as you can. You have all these meetings, and management said, "Hey, yeah, this point hasn't even come yet. Don't read that sentence yet. We'll come back to it." You go ahead and start having your meetings with the team you chose to help you with this project. Everybody's saying, yeah, here's what we need to do. We need to do our study feasibility, purchase the building. We don't have any space to do these new loaders. We gotta hire a project leader, you know, because we all gotta do our regular job. We're just planning this all out. Select advertising staff, purchase materials, hire a management staff, manufacture a prototype, produce first 50 units, advertise the product, and get it sold. These are the activities the group came up with that you're leading. Here are the activities that would just be finishing as the other activities are going to start. So study feasibility is right as it finishes, we can start purchasing the building. Right as it finishes, we can go ahead and hire that project leader because the feasibility is probably giving us a positive. Go forward, this could be profitable. You got this? And you went ahead and came up with actual times. This isn't even, in real life though, this would be uncertain times, and you'd have 3 of them. But right now, let's say every activity, we got to pinpoint it as to how much time would be spent. We have subcontractors involved. And we had to figure out the cost and even using our own people to do some of these activities. And we came up with, hang on, where is it? Like magic. These costs, right here. Here's our cost we came up with. Ignore this for a minute, right here. Here's how much time each activity can take. We can go back and see which one precedes the others. And here's our cost for each one. Here's our, if you add them all up, here's our total cost to get this project going. Here's how much money we need. Then management gets your whole report. You're about to get started. The feasibility study's actually begun. And they said, how much time is this project supposed to take again? And you said, I did a forward pass, backwards pass, and it's supposed to take, how much time is this project going to take?
30 weeks.
30 weeks, or 30 units of time. Both I and H go to the end because they don't precede anything. The earliest it could finish is 30, earliest it could finish is 28. They both have to be done for the project to be done. This project's going to take 30 units of time, weeks in this case. That's not good enough. No, this needs to be done in 26 weeks, not 30. We've got to get this done in a half a year. No matter what it costs. You hear that? No matter what it costs. But as the project leader, it's your responsibility to come up with a plan to get it done in 26 weeks at the least possible cost. Even though we know it's going to cost a lot, your job is to get it done in the least possible cost. Everybody gets on the phone. Hey, is there any way of getting the feasibility study done faster? Yeah, sure. Who did you subcontract it for? You talked to them? We could get it done a week earlier, but I've got to get somebody else to do the environmental study part of it, something like that. And so it's going to cost an extra $20,000. So it brings your cost up for this activity to 100. Right? I used to always form 2 columns at this point. My first column, darn, this is going to be off camera. This first column is number of periods that you could possibly crash. Activity A, you made the phone call and they told you, here's A, I know you can't see it, 1 possible unit of time could be crashed with that one, and that's it. That's all they could do. This is the best we could do. How much is it going to cost? This is your cost for crashing, $20,000. You could purchase the building. You subcontracted that out, or maybe you're in-house. You have the conversation. Hey, I know you said it's going to take 4 weeks to pinpoint the building, work out a purchase agreement, get to a closing. You know, I bought a lot of buildings, so it takes a lot longer than 4 weeks, by the way. And close on it and everything. You know, what can we do there? That is the fastest I can get that done, you hear. There is no way we can get this building scoped out, make sure it fits everything we need, meets our needs, purchase agreement, get to a closing, environmental study. Every time you buy a commercial building, by the way, you've got to do an environmental study because you don't know what's underneath it. I've been in that situation where we were at a closing and found out there were gas tanks underneath the ground. From a gas station was there like in the 50s. Didn't even know it was ever there. They never brought the tanks up. If you buy that land, now that everybody knows it's there, you have no choice but to pay all that money to get those tanks out of the ground. We looked at the cost of that and said, okay, now this is no longer our prime location. We started looking for another piece of property. We called off the deal. So there's no way it could get done in more than 4 weeks. So in this case, we got a big zero, it just can't be crashed. That happens. Some of these activities cannot be crashed. 3, hire someone, human resource said, yeah, we can speed this up. We can even, you know, blah, 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 blah. We could cut off 1 unit of time, 1 week, and the cost would be, the difference between what it usually would cost and what the new price would be because of this, it's an extra $50,000. And you keep going down the list, and this is exactly how it works. You have these conversations, one after another, as fast as you can to come up with this plan. And here's your information. Select advertising staff. You can cut literally 3 weeks off this project, and for an additional cost of $150 to $300, that's $150 extra $1,000 to take 3 more periods off of that activity. And so on. Here's a 1, here's a 3, here's another 0, can't be done on manufacturing prototype. Here's a 1, here's a big 4. And you get your total amount of money. And then you have this column. This is the major column. And this is per 1 unit of time. $20,000 to crash, we can gain 1 unit of time. The cost per 1 unit, I'm abbreviating now, $20K. B is out of it. C, $50,000 total, 1 unit of time, we divide that, we get 50,000. What is this, D? D, we could crash, we could gain 3 units of time for an additional 150,000. 150,000 divided by 3 per 1 unit of time would be 50,000. See what I did there? You would do that. Let's go to the bottom one. 4 units of time, additional cost, what is that, 300,000? Take 300,000 divided by 4 per 1 unit of time. Calculators.
25.
Say it again, I didn't hear it.
25,000.
25. Oh, 75, thank you. 75,000 per 1 unit of time on that one. So it's just taking the total amount of cost divided by the number of units, because to find that 1 unit. By finding the 1 per 1 unit of cost, you're just basically writing your objective function. Those numbers in the last column, 20, 0, 50, 50, and that bottom one, 75, 20, B's not in there because it's 0, 50, 50, 75 is your objective function. So that's what this is all about, to find that cost per 1 unit. And it's always multiplied by the y variable with the little activity. What is the activity? This is activity A, activity C, activity I. It's the y variable in your objective function. So that's how you come up with that. You'll always be given this. All this work will be done for you. You're given, here's the cost we found, here's how many units. You just need to quickly come up with the cost per each 1 unit of time you could crash for every activity. And you got your objective function. This other column, where you calculated how many units of time could be crashed for every activity, you just wrote your y constraints. Y sub A less than equal to 1. Y sub C less than equal to 1. Y sub D less than equal to 3. Everybody see that? So that's how these y constraints. Y sub A less than equal to Y sub I less than equal to 4. It's the number of units that could be possibly crashed for each activity using the y variables. Y represents units crashed. That's what that variable represents. Y is the units crashed. Okay, number of units crashed. You got that. So objective function, y constraints, they're easy, right? You just got to do the math when you get this. Now, you get all that done, and you look at this. You say, okay, I'm ready to write my activity constraints. We're doing that time. We're doing okay. I need to write my activity constraints. And here's how to do it. It's always the x variable of the activity. We'll do it up here. So that we're starting with A. Greater than equal to the proceeding, how do I put this? The proceeding activity. And I don't want to base me there because it's not preceded by anything. Whatever activity precedes it, x variable. So if I were looking at C, x sub C greater than equal to x sub what precedes C? A. Plus, oh yeah, look, it's been a long time. Is it really plus? Yes. Plus, let me just go right to it. Plus, parentheses, the normal amount of units of time that activity C that we're writing this for is supposed to take. So when you look at this, what's the normal or usual amount of time C would take if we were not crashing this? 3. Minus the Y variable for whatever activity you're writing this for, which is C. So everybody, I want to say this again. It's the X variable for whatever activity you're writing this activity constraint for, greater than equal to the X variable for whatever activity precedes the activity you're writing this for, plus parentheses, the normal time that the activity you're writing this for is supposed to take, minus the Y variable for whatever activity it is you're writing this for. You've got to go one step farther that you won't see on the PowerPoint. You've got to use algebra to get your variables to one side, left side in this case. So if I take the parentheses out of there, I got X sub A plus 3 minus Y sub C. I'm going to subtract X sub A on both sides, and I'm going to add Y sub C on both sides. So I get X sub C minus X sub A plus Y sub C greater than or equal to 3, and now it's done. Let's go back and do another one. You ready? I want you to help talk me through this by finding a ratio. Okay, let's do activity E. Activity E, you start with the X variable. There we go, greater than or equal to, what precedes E? B, use the X variable for B. Plus, parenthesis, what is the usual time for activity E? 3 units of time. Minus Y sub, what letter would go with this Y? E, because we're writing this for E. Let's use algebra. Subtract the X sub B, because it's positive on this side. It's a negative Y sub E, so add a Y sub E to both sides. So I got X sub E minus X sub B plus Y sub E greater than or equal to 3. And now it's ready to be entered into the computer. This would be a positive 1, that would be a negative 1, that would be a positive 1. If you had all the variables at the top of the software, you would put a 1 underneath this one, a negative 1 underneath that one, a positive 1 there. You put greater than, and on the right hand side you put a 3. And that's how you enter it into the software. If you were using linear programming. The only way to do crashing is linear programming module. You can't use the project module for crashing. It has no crashing abilities on that module. All right, help me out. Let's do another one. One more. Here we go. You ready? We're going to do F. X sub F greater than or equal to, what precedes F?
C and B?
What? I hear B, I hear C. What's going on? That's right. Anytime you have an activity that's preceded by more than one activity, you got to write as many constraints as it has in preceding activities. Because F is preceded by 2 different activities, I have to write 2 constraints for activity F. They're exactly the same except for what you're putting right here for the preceding activity. F is preceded by B, so I'm putting X sub B plus parentheses, the usual time for F is 10, is that right? Minus Y sub F, and then I got to do this again. X sub F greater than or equal to, this time it's X sub C plus 10 is the usual time for F, minus Y sub F. There's no difference between these 2 constraints except for one is being preceded by B, the other one by C. And so if you look, you'll notice you're going to have to write 2 constraints for I, 2 constraints for G, and those are the only other ones other than F. Is that right? Am I missing something? So I'm going to have activity constraints 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, plus 2 more. Because I have 2 activities going to the finish that don't precede any other, I have to make them X variables less than equal to whatever it is I'm trying to crash this to, which is 26 weeks. That makes 14 activity constraints. So let's make sure we're right here. Here's our A, our B, our C, our D, E, 2 Fs, 2 Gs, H, 2 Is, and then our 2 activities that do not precede any other activities less than equal to whatever it is we're crashing. Remember, all of these are greater than equal to. Only less than equal to right here are the ones at the very end that we're crashing to the amount of time we're trying to crash to. That covers all of those. I broke that down. You should be able to write this easily. You could, as long as you have a drawing like this, and you have this, just those 2, you can write all of these by following that logic if you took good notes. But you have to be able to interpret the output. Okay, you got this crash to 26. What's going to be your cost? What's the lowest cost you were able to get this to crash this to 26 weeks? That's right, $200,000. Which activities are being crashed and by how many? Just name one activity that's being crashed. What do you look for? Sorry, so, what did you say? The what IT? Sorry. SDAT. No, not the most numbers, but you're on the right track. What do you look for? Anybody? Huh?
Cost.
Now we got cost. Which activities are being crashed? Name one. What are you looking at to tell me which activities are being crashed?
The ones that don't have 0.
No, not the ones that don't have 0. I heard over here.
Is it the Y variable?
The Y variables are the ones that represent the crashing. Name an activity as being crashed. F I hear. How many units is F being crashed?
3 weeks.
You got it. Name another activity being crashed. A. How many units? You see any other activities being crashed? Now the bigger numbers that are with the X variables are telling you, you could go to the biggest number and that will tell you how many units of time is the expected completion time now that it's being crashed. How many units of time is this going to take now that it's being crashed? 26. 26. Right there. These are where you want to look to figure out which activities. If you go back and look at F, and look at what the cost is, I don't know if we did F. A, B, C, D, E, F. We didn't do F, but if you look at the cost and multiply it times 3, you go back and look at A, which we did at 20,000 times 1, so that means 200 minus 20 means this is 180, so this must have been 60,000. 60,000, 60,000, 60,000 is 180,000, plus 20,000, that's how it got to 200,000. And that's the least expensive way to get this to 26 weeks out of all the possibilities that could be crashed. So just go right in and go, we're crashing F, we're crashing A, here's how many we're doing it, and here's how much we're spending to do it. And this project's going to cost us $200,000 more dollars, but we're getting it done in 26 weeks, just like management wants. All right? We got it? This was too easy, right? You're done with the chapter. What? What? Oh, wait. Almost forgot. Almost done. Let's demo this real quick. Ready? I want you to have PowerPoint page. How much time we got? We got just 5 more minutes. Let's go back to where's the here's our units of time, expected time right here. No, we need this. Someone have this page. A couple people have this page in front of you because I'm going to start asking questions about what are the 3 times, what activity precedes it as I'm showing you the software. You ready? Somebody tell me they're ready. Okay. Camera's rolling. I'm going with the module for project planning right there, per CPM. Open it up. We're going to do a brand new one. This is uncertain activity times this time, and the number of activities. How many activities are on that page?
11.
11, thank you. 11, hit OK. Looks just like that. We'll start with A. A 3 times. Was it 4, 6, and 8?
Yes.
4. Did we do this already? No. Okay. 4. Trying to remember, but if I hit enter this, I think it's gonna stop, so I gotta hit the air, hit my pointer. 6, you have to hit the pointer, I think. 8. Now I'm gonna go to B. Is B preceded by any activity? No. Okay, so what are the 3 times for B? 1. 4.5? And 5. Okay, is C preceded by any activity?
A.
A is? Just A is the only one?
Yeah.
Okay, 3 times for C.
3.
3.
All 3.
All 3. Oh, that's what's going on. Okay, is D preceded by any activity?
A.
Just A.
Yep.
And the 3 times for D.
4, 5, 6.
All right, so you see how this is done? And you got, wow, you got fast. C is preceded by A with a 3, 3, 3. D is preceded by A with 4, 5, 6. E, and so on. See how I did? Got it. This is how you enter it all. You got it all set up. It looks just like that page on the PowerPoint, right? With what precedes it, what the times are. Then you hit solution. What is the expected? Hang on. I don't want to give away everything. Hang on. Boy, will this work? This is not. Oh, darn it. Okay, without going any farther, is the last activity K? Yes. What's the expected completion time of this activity if this is all you can see?
23.
23. Whatever the biggest, latest finish number is, I'm sorry, earliest finish. Whatever the biggest, well, it doesn't matter really, earliest. The biggest number is, when you look at the finishes, that's the project expected completion time. 23 units of time. Which activities are critical?
A.
There you go.
C,
That's right.
F.
It's in 2 places. They'd have either 0 slack or you'd have a yes under the word critical. So if you don't have the yeses here, you just got to look at the slacks. 0 slack means it's critical, right? Let me go a little farther down. Sure enough. Oh, that's okay. And with the software, you're given the critical path, which is ACFIK. Completion time, 23. Project variance, not standard deviation. You're given the variance of the project, which is basically taking ACFIK's variances and add them together, which is 2. Then you need to then take 2 and square root it to get to that project standard deviation. What's nice about the software is you probably need to show manually to get that project variance. Show me you calculated the variance for just the critical path, and show me you added them together. But you can use the software to make sure you're correct. If I give you a problem where you've got to do a forward pass, and you've got to give me that completion time, after you show me the numbers forward pass, and you want to make sure you have the correct completion time, you just quickly enter it in the software. You can check and make sure you have the correct project completion time. If you got time. If it's a quiz, you may not have time. But everybody see what's expected, right? So, do it. Pick your groups. What? What? What?
Down to like